Today I'm going to demonstrate how to cut gears using a rotary table and a mill to create a gear that matches an existing gear. This is for my orrery project. I'm going to be using this rotary table. The rotary table allows me to rotate a workpiece through a specific angle by turning this hand wheel. Every time I turn this hand wheel one turn completely around back to zero, I go through 4 degrees. Today I'm going to be making a 35 tooth gear, so I end up having to turn through an odd angle for each turn. So I'm going to show you a technique I developed for making that process as simple as possible. I'll be making the gear from this 1-inch strip of brass that I got at the hardware store. It's 0.09 inches thick. The gear will be cut from it like that. First thing I need to do is center my mill. The rotary table's already been centered in the Y direction. I've done quite a few of these. So I just need to recenter it in the X direction, or from side to side. This is an edge finder. Normally it's used to just find the edge of a workpiece, but I'm going to use it to find the center of this hole. I'll be using the mill more as a drill press today than as a mill, because we're just going to be drilling holes around in the center of a circle. The first thing I'm going to do is lower that down into the Morse taper hole that's in the center of the mill. Clamp that in place. We start the mill turning. So what I'm going to do is I'm going to find the left edge of the hole. And you see how this works. As soon as I hit the edge, you can see how that moved out to the side. Now I'm going to take the slack out of my wheel, set that back to 0. I'm going to count the number of turns to get to the other side. So 1, 2, 3, 4, 5, 6, 7, and I'm starting to come to the edge here. So I did 7 turns and 50 thousandths. Each turn on the X table is 62.5, so I did 7 of those plus 50 thousandths. So I want to go back the other way halfway, which is 243 thousandths and 0.75 thousandths. I'm going to divide that by 62.5 so I can get the number of turns. So I'm going to go back the other way, 3.9 turns. So I'm taking the slack out of the thing, and 1, 2, 3, and 0.9. It's 56.25 minus 62.5. I'm going to turn this back to 6.25. That should be my center, which is right about there. So now we're centered and ready to start our gear. So I've cut out a small piece of the brass to make the gear with. The first thing we're going to want to do is mount this in the center. I have a small center drill that I'm going to mark the center with. And then we're going to drill the center hole where the hub will be on the gear before we do the offset. So I have some mounting clamps here. And I've put a little X in the center. I want this to come right down in the center of this because I need pretty much all the brass from side to side over the 1-inch thickness. And if I don't come right in the center, I'm going to run off the edge. So I'm going to tighten these clamps down. My brass piece is centered, very solid, so I don't think that's going to move around too much. So I'm going to mark that center hole. And that's going to be the center of the gear when we're done. So I'm going to drill a hole that I can put a number 832 screw through. So I'm using an 18 drill bit, which works pretty good for that size. I do have an aluminum scrap piece underneath, so I don't drill into the actual rotary table when I'm drilling. That's good enough for that. Now we're going to do our offset. So I calculated for 15 threads per inch, or 15 teeth per inch, and 35 teeth with a number 61 drill bit, which is 0.039 inches in diameter, that I would need to be 390 thousandths offset from this center point for my ring of holes that go around the outside. So I'm going to loosen the clamp that's holding my X in direction. I'm going to re-zero this. So I'm going to go 390 thousandths, or 6.24 turns. So 1, 2, 3, 4, 5, 6. I need to go 0.24 yet, which is 15 thousandths, which means I have to turn this back to 47.5. Right about there. Now we're going to put in our center drill. If I bring this down over the workpiece, you can see I'm going to make a circle all the way around that center hole when I turn the rotary table. That's 390 thousandths, or 0.390 inches from the center of the gear. So we're going to start. We're going to call this 0, starting point. So I have the hand wheel turned to 0. What I usually do is, so I can keep track of where 0 is, I put a little piece of tape right here. And I just want to tap this into the surface a little bit. So I'm going to put in the depth that I want, and then I'm going to set my stop right here up so that I'm stopped right there. So you see it's put a little tiny mark in the surface. We only need a little tiny spot like that because we're going to be drilling with the number 61 drill bit. I don't want to drill directly into the brass because the tip of the drill bit will tend to walk around the surface and I won't get my holes in the exact locations where I need them. So I use the center drill bit for the first time around, and then re-drill the same holes with the number 61 drill bit. Now my table's set up so I can check off when I've done a given drill. So I'm at my 0, 0, 0 line, and I drilled a center hole. This is going to be for the first center hole. This is going to be for drilling the hole. This is going to be the second centering when I move out, and this is going to be for the final drilling. 35 more drills, center drills, and then 35 drills with the number 61. Then I offset it, center drill, and the number 61 again. But the first turn listed here in the center under turns, degrees, and seconds, so I'm going to turn the hand wheel 2 turns, 2 degrees, 17.1 seconds. So the first thing I do is I loosen the mill, and I'm going to go 2 turns, 1, 2, and over to 2 degrees. And I'm going to estimate 17.1 seconds. I'm going to clamp it back in place. And we'll make our second mark. Now the way the table's set up, what I do is re-zero the hand wheel. So I'm going to turn it back to 0 before I do my next turn. I do this because it's easy to do number of cranks around 0, so I send it back to 0. This will also cancel out any error that I did from accumulating every time and eventually getting me way off. So I'm recentering the 0, and then I check off that I've done my 17.1. So the next turns are two turns and 34.3 seconds. It's subtracted off what I did on the first turn going back to 0. So I'm going to go 2, 2, 1, 2, and then 34.3 seconds. I'll clamp everything back in place. We'll make our next drill. Okay, now we're going to turn it back to 0. Then I'll check my next. Is 1 turn, 2 degrees, 51.4. So I'm going to do 1 turn plus 2 degrees, 51.4 seconds. So this process continues till I do all 35. What I'll do is I set this to fast motion so that I can get all 35 marks, and we'll stop, and I'll put the drill bit in, and we'll go through the second run. So the normal way of making a gear on a rotary table would be to have the rotary table upright and use a double angle slot cutter to cut each gear, and you don't have to drill all these holes and you don't have to do all the filing. So why am I doing it this way? These gears are very small, and I couldn't really find a slot cutter with a fine enough point or an acute enough angle to cut the gears properly. So I came up with this method for making the gear. It's tedious, takes a lot of work, but it's also a lot of fun. So here I've stopped the mill, I put the number 61 drill bit in, and now I'm going to continue around the circle drilling the through holes. So that completes the through holes on my first ring. Now I'm going to increase the offset by 40 thousandths. That's about the diameter of the 61 drill bit. So in the end I'll have two 40 thousandths inch diameter holes right next to each other, radially out from the center of the gear. Here I've switched out the number 61 drill bit back to the center drill. I'm 40 thousandths out from the original holes. Now, similar to the first set of holes, I'll first drill with the center drill, each one of the 35 holes, and then switch that out to the 61 drill bit and drill the through hole. And that will complete all the drilling needed for this gear. I won't stop recording through this part and just come back to you when it's completed. We have completed the second set of holes going around the center of our piece. We will now remove piece from the mill. We have two sets of concentric holes going around the center of what will be our gear. We're now going to trim that so we can turn it on the lathe. I'll be using the bandsaw to trim. So I've rough cut it. I will take and file those tips flat. It'll make it a little easier to turn when I put it on the lathe. So these jagged tips, when I put it on the lathe, mounted to the lathe, will kind of catch on the cutting tool. So I'm going to sand that a little flat on each side. So now it's ready to be mounted in my fixture for turning. This is the fixture. It's just an aluminum rod that I bored a hole down one end, and then drilled and tapped it to an 832 thread size, so I can put 832 screw in there. So the screw goes through the center of our gear. There's a little star washer on there to keep the gear from spinning when I'm turning it on the lathe. And then we just mount it to our aluminum rod. We'll tighten that with a screwdriver to make sure it's good and tight. All right, now the piece is ready for turning on the lathe. Chuck that up. So we're basically going to be spinning that and cutting it with our cutting tool. We're going to cut that into a circle or a disc, and then we'll be ready to trim out the gear pieces. We've got it cut round. We're going to measure the diameter and see how much more we need to take off. Looks I'm at 925 thousandths. We want to go from 925 thousandths down to about 865. So you take off about 60 thousandths. So I'm going to take about 10 thousandths off of each pass. So we've got to go 12 passes. All right, we're right there. So our piece is cut into a circle. We have our holes drilled. Now we're going to trim those back on the Dremel. This is a Dremel set up on a drill press unit for the Dremel, but you can turn it sideways for doing this kind of work. I'm going to use this aluminum block as kind of a steady rest table, and then I have a cutoff wheel on there. So that's our gear so far. Take it off of the lathe mounting fixture. There's our piece so far. I'm just going to sand the rough edges off. Here's our piece ready for trimming. It's going to be trimmed and then filed to fit that gear. The first thing we need to do is trim it. We're going to cut the holes together. We're going to cut the holes open on the one end so that we can use a file to kind of do the final fit. So the aluminum block acts as a rest for while I'm cutting each tooth. So our gear has been rough cut. Now each tooth will be filed into shape. I found what works really well is to put it back into the lathe mount. And then just keep it in the vise. And I go around and clean up each tooth. All right, the gear looks like it's finished. I've been filing for quite a while, fitting it individually so that the teeth will all mesh to my larger gear, my 48 tooth. So this gear is completed. Lay it in next to our matching gear. The Rotary requires a 48 to 35 tooth gear for my Mars to Earth connection. You can check that out on my Rotary 2 website. I needed 2 gears, 2 of each, 2 48s and 2 35s. There are the completed gears, ready for the Rotary. So you can check out jeffreysodeman.com. You can look at both of my Rotaries. I have Excel spreadsheets for calculating gear ratios and gear diameters for making similar gears, and calculators for determining what gears to use to make an Rotary. Check it out, and I hope you enjoyed this video.